All right, so we talked about atomic structure and the parts of the atom yesterday. So today we're going to talk in more detail about each part and then how to figure out how many of each there are. Some of this, again, may be review from physical science, but it's not really something people tend to remember year to year. So I would like for you to write everything down, just like if I were giving these notes to the class. You will not get a guided sheet for this because I want you to write everything you see on the screen as you listen. All right, so first we're going to talk about the periodic table. The periodic table we're going to use from this point forward. It has a lot of information on it that we'll talk about at little pieces of time. Every periodic table you use, whether it's the one I give you or if it's a different one, will always have a key on the periodic table that tells you what each number or symbol or word represents. The periodic table I'm giving you is set up like this block that you see here, with the name of the element at the top, the atomic number next, the symbol of the element, and then the average atomic mass. Yes, I would like for you to sketch this in your notes. So the atomic number is going to tell us how many protons are in an atom. So for example, if you look back at the sketch you just made, hydrogen's atomic number is 1, so it has 1 proton. The number at the very bottom of the box is something called average atomic mass, which we'll talk about in a lot more detail in the next couple of days. But basically, it's the average mass of all the atoms' isotopes. So what is an isotope? Elements exist in different forms. And the difference between the two forms or three forms or however many there may be is that there are different number of neutrons. So protons will always be the same. So for hydrogen, it will always have 1 proton, but it could have different numbers of neutrons. And so we indicate isotopes one of two ways. One is writing the name of the element dash a number, and that number is the mass number. Or you may see it written like this, with a symbol and then a number at the top of the symbol and a number at the bottom of the symbol. So the top number would represent the mass number, and the bottom number is the atomic number. And a lot of the times people confuse those because the periodic table is backwards. The atomic numbers at the top and the mass numbers at the bottom. So you just need to make sure that you know when you're writing isotope notation, which is what this is called, the mass goes on top and the atomic number goes on bottom. And then X represents whatever the symbol of the element would be. So if it was hydrogen, the symbol would be a capital H. So when I give you an isotope, I will tell you the mass number, and the mass is the protons and neutrons added together. Remember, protons and neutrons are in the nucleus, and when you add them up, it gives you the mass. Yesterday we talked about how much bigger the protons and neutrons are compared to the electrons, and so they make up most of the mass of the atom, and so that's why we just call the mass the sum of the protons and neutrons. So now we need to move into how do you know how many of each particle there is? How many protons, how many electrons, how many neutrons? And so first, the protons is given to you by the atomic number. So if the atomic number is 5, that means there's 5 protons. Now, protons can never change. So if hydrogen has 1 proton, it will always have 1 proton. If you change the number of protons, you're actually changing the identity of the atom. So that's why these have to stay the same. Neutrons, remember the mass is the sum of protons and neutrons. So if you're just trying to find neutrons, you'll take the mass and subtract the protons. And electrons are the same number as the protons. Now, in parentheses here, it says in a neutral atom. For now, you can assume that all atoms we talk about will be neutral, which means electrons will equal protons. Later on, we will get into not neutral atoms, but right now you can assume that they're all neutral. So those two things, the P and the E, will be equal. All right, so let's look at some examples. So how many protons are in these three elements? So remember, protons are equal to atomic number. So pull out your periodic table and find phosphorus. Phosphorus is a capital P, and its atomic number is 15, so that means it has 15 protons. Chlorine is atomic number 17, so it has 17 protons, and argon is number 18, so it has 18 protons. Now, remember these numbers out to the side of the names are mass numbers. They have nothing to do with the protons. Now, electrons, assuming they're all neutral atoms, we remember from a few slides ago that protons and electrons are equal. So again, you would look at the atomic number, and so they would be the same as what you put for protons, because protons and electrons are equal for now. All right, neutrons. Neutrons the fun one, because that's where you have to do some addition or subtraction depending on the information they give you. So remember, neutrons is the mass minus the protons. So the numbers out to the side of these isotopes are the mass. So phosphorus's mass in this case is 30, and its atomic number, which is the same thing as protons, is 15. So I subtract 15 from 30, and I get 15. So this isotope of phosphorus has 15 neutrons. Chlorine, 35. So 35 minus the atomic number of chlorine, which is 17, and that gives you 18 neutrons. Argon's mass of 40, subtracting atomic number 18, would give you 22. So that's how you find protons, neutrons, and electrons.